Hello friends, today I have brought the contents for you, that is the design of 3-phase 4-pole wave winding. This 3-phase 4-pole wave winding design, when you see, you will understand this is the diagram for 3-phase induction motor. Moreover, I could say this is the diagram, or this is the waveform this is the winding diagram for 3-phase induction motor. In 3-phase induction motor, the winding is needed in two parts. One is stator, which has the winding. The second part is rotor, right? In two parts the winding is present. So this diagram which we have developed here, or the waveform which we have developed here, this is the winding diagram for stator of 3-phase induction motor. Generally we need to understand 3-phase induction motor has the winding in stator and rotor, out of which the stator winding we are talking about. Then there will be a question that why, first of all I could say why the winding is present, why the winding is needed in stator of induction motor. So the answer is very simple. For this, the stator of induction motor, you can imagine the stator diagram. Here the winding is present. The reason behind this winding is this winding will produce a magnetic field. So basically the reason for having the winding in stator is to produce the magnetic field. When magnetic field is produced here in the stator, that magnetic field links with the rotor conductors. So when it links with the rotor conductors, EMF gets induced in the rotor conductors. When EMF is induced in the rotor conductors, then rotor conductors, those are short circuited generally, will be considered as current carrying conductors, and these current carrying conductors are placed in the magnetic field. So when they are placed in the magnetic field, they will start experiencing the force, and according to that force they will rotate. This is the basic principle of working of induction motor that is known to all of us. Now in this winding there are so many things to understand. This is actually very interesting thing to be known, or this winding diagram is very interesting to understand. Problem statement, if we go to the problem statement, is simple. Develop a winding diagram for a 3-phase 4-pole induction motor. Use double layer wave winding. That's what is given. We need to use double layer wave winding. So from this I have understood few things. What are those? My motor is 3-phase induction motor. That is first thing I have understood out of it. Then the number of poles are P is equals to 4. Number of poles are 4. This is an induction motor, that is also known. Winding is double layer. Double layer. This winding is double layer. That we need to understand out of it. Now see, when we are thinking of the winding, there are different parts or different things those are associated with the winding. First of all, we need to understand any winding is made up of the conductors. So say these are the conductors, two conductors. When these two conductors are connected together, we are calling it as a turn. This becomes turn. That is, I could say, one turn. This structure where two conductors are connected together has formed one turn. When such n number of turns are connected together, that becomes a coil. When n number of turns are connected together, we'll be calling it as coil. So in this turn, we need to understand these are the two conductors, conductor number 1 and conductor number 2. So this length of conductor is called active length of conductor. Active length. See, this is very important, friends. This length of conductor is called active length of conductor. The reason behind calling this as active length is because this is the length of conductor which is going to contribute in production of magnetic field, or this is going to produce the magnetic field which is useful for the working of machine, for the working of motor. That is why this length of conductor is only called the active length of conductor. Then there will be the question that if this is only the active length of conductor, what we call this part. So we need to understand, friends, this part which is shown here, will be calling this part as overhang. This is called overhang. Then what is the purpose of this overhang? Purpose of overhang is to connect the conductors, first purpose. Second purpose, to provide the mechanical strength when this winding is placed in the slots. When this winding is placed in the stator slots, this part is going to provide the magnetic strength. So this is a overhang. Same way the part is present. Same way the overhang which I have drawn, see, two conductors, this is the active length of conductors, this is overhang, this part also I am calling it as overhang. So this is a overhang, this is also a overhang. So you need to remember overhang part. Okay, and this was the active length of conductor. Now let us come to the discussion of the problem statement which is given. We have been given that there are total 24 conductors. Okay, 24 conductors are there, and 24 conductors are there, 24 slots are there. We need to understand. So see, if 24 slots are there and 24 conductors are there, I could say there will be one conductor per slot. For this diagram, there will be one conductor per slot. This information is given in the problem statement, that 24 slots are there, 24 conductors are there. So if 24 conductors are there and my machine is 4-pole, see what I'm saying, 24 slots are there and 4-pole are there. So slots per pole will be 6. 24 by 4 becomes 6. 24 by 4, that is slots per pole, 24 divided by 4 is going to become 6. This 6 is going to give us the distance between two poles. Am I right? If there are 24 slots and there are 4 poles, I could say 6 slots is the distance between two poles, and this distance between two poles is nothing but the pole pitch. This is called pole pitch. So pole pitch is nothing but the slot wise distance between the two poles. Between any two poles, how many number of slots are there, those we need to measure, those we need to count, and that will be nothing but the pole pitch. Okay, likewise there is concept of front pitch and back pitch. For front pitch and back pitch is also the concept. For the winding diagram we are going to produce, that is wave winding, front pitch and back pitch is equals to pole pitch. Front pitch is equals to back pitch, and that is equals to pole pitch, so which is 6 for this diagram. This front pitch is nothing but the distance between two conductors when the winding is moving in forward direction, front direction. Back pitch deals with the back direction, when connections are connected in back direction. If there are n number of conductors, then n can be considered as the front pitch and back pitch of this diagram. Okay, so here we know the front pitch is 6, back pitch is also 6. It is represented generally with YF, YB is back pitch, and YP is pole pitch, which is also 6. That's what is understanding out of it. Now if I look at this, there are 3 phases, as this is a 3-phase diagram, 3 phases, and there are total 24 number of conductors. Conductors are 24. So 24 conductors divided by 3 phases. I am going to calculate how many conductors per phase. 24 by 3 becomes equals to 8. 8 conductors will be there per phase. Per phase there will be 8 conductors. And same way I could say 24 divided by 4. 24 is number of slots, 4 is number of poles, so which becomes equals to 6. 6 is the distance between the two poles. When poles are formed, the distance between two poles will be 6 slots, or here in this case that will also becomes equals to 6 conductors, because in each conductor there is in each slot there is only one conductor. So that is same thing here. Okay, now in this winding diagram there are many things to understand. As I said, it is really going to be the interesting session. See, as I said, this is going to be interesting session. In this diagram, from the winding diagram itself, we could identify whether it is a AC winding or DC winding. Even though any data is not given to you, no problem statement is given, no title is given, still we could identify whether it is AC winding or DC winding. I am going to tell you how to identify that. That is really important and very easy and interesting also at the same time. So we will understand whether it is AC winding or DC. So first of all, if I observe this winding diagram, I could find there are three colors used. Three different colors are used, namely red, blue and yellow. So they will be standing for, these three colors are standing for, if you look at R for red, Y and B. So RYB, these are generally the representations of three phases. So this is a three-phase winding diagram. By looking at this, I could identify. Apart from that, sometimes people may get confused that whether it is a DC winding or AC. This diagram is easily you can identify is three phase. In some other diagrams, there is a problem to identify whether it is AC or DC. So that could be identified very easily with the understanding that we know that the DC motor needs commutator and brushes. These are two important parts of DC motor. So if commutator and brushes are present in the diagram, that is the diagram for AC that is the diagram for DC winding. While if commutator and brushes are not present, that is the diagram for AC winding. That's what we can understand. And if you want to represent the commutator and brushes, those could be represented here. See, likewise, if I represent it here like this, these are the commutator segments, and over the commutator segments only there will be the connections from brushes, and these conductors may be connected to the commutator segment. If such structure is present, that is a DC winding. If such structure of commutator and brushes is not present, it is absent, it is a AC winding. The understanding, I hope, is clear to everyone how to identify whether it is AC winding or DC winding. So this is again something interesting. Then several times the question comes that whether it is a the winding which is drawn here, the winding diagram, whether this diagram has the phase sequence RYB or it is RBY. Because if I look at this diagram starting from this part, first I find R, red conductors, then I find blue, and then I find Y, yellow conductors. If I enlarge this, you can easily identify. See, if I enlarge the diagram, you can easily identify. First one is R, then there comes B, and then there comes Y. There may be question in your mind, why first two conductors are red, next two are blue, and next two are yellow. The reason behind that is two conductors. Here two conductors are placed for each phase. Each phase has first two. So first two red conductors are for R phase, I will say. Next two are for B phase, next two are for Y phase. Reason behind that is the winding diagram is double layer. This is the meaning of double layer. And then let us come to the phase sequence. Generally the winding diagram, any winding diagram must have the phase sequence to be maintained, that is R, Y and B. This could be the generally phase sequence. Here if I observe the diagram, I could say the phase sequence by observation. I could say the phase sequence is R, B, Y, but that is not right, friends. The phase sequence for this diagram is also RYB. How? We are going to see that. See, as we know, there are total 24 conductors. 24 is the number of conductors we have, right? When these 24 conductors are placed in the stator, 24 conductors are placed in the stator, I could say they are placed across 360 degrees. Hope everyone will agree. So 24 conductors are placed in 360. 360 divided by 24. What I am calculating is I am calculating the distance between two conductors, degrees, distance in degrees between two conductors when these conductors are placed in the stator, right? So if 360 degrees is the total distance, this is 360 degrees total. 24 conductors are there. If I take this ratio 360 by 24, it becomes 15 degree. So I have understood the distance between two conductors is 15 degrees. Likewise, I also know when three phases are drawn, three phases RYB, these three phases has the phase angle of 120 degrees with each other. This distance is 120 degree, this distance is 120 degree. So the phase sequence could be RYB if After the start of R phase, Y phase comes after 120 degrees. We could say the phase sequence is RYB. So I need to check whether this condition is satisfied in this diagram or not. If this condition is satisfied, that after R phase, what is the condition? Condition is after R phase there could be distance of 120 degrees between Y, RY 120 degrees, Y to B there could be 120 degrees. If this condition is satisfied, then we could say the phase sequence is RYB. And we have just now calculated that distance between two conductors, any two conductors, is 15 degrees. How I have calculated? 360 divided by 24 conductors. I come to know that 15 degrees is the distance between two conductors. So I will start from R phase. After R, this is R phase which is finished here. After R, I am going to calculate 120 degrees, where those 120 degrees will come. So see, 15, first conductor is at 15 degrees, second at 30, 45, 60, 75, after 75 becomes 19, 105 and 120. So here 120 degrees finish. So after 120 degrees from R phase, I have counted 120 degrees. So after this 120 degrees, which phase is present? That is Y phase. Hope you understood. Likewise, the Y phase, when it finished here, after 120 degrees of which this Y phase, there must be B phase. So let us count that also. Y phase is finished here, Y phase, right? So I will count from here, or moreover, if you want to continue from the first part itself, see, this is R started with. After R, 120 degrees will be here, and next one is Y. After this Y, now I am going to count 120 degrees more. So after this Y, I am going to count 120 degrees more. So Y phase is finished here. Then 15, 30, 45, 60, 75, after 75, 90, 105, 120. After 120, there will be a B phase. So the phase sequence for this diagram is RYB, and it is not RBY. Even though you find in the diagram the phase sequence RBY, but still it is not true. Even though it looks like RBY, it is not true. The phase sequence for this diagram is RYB. That's what we need to understand out of this. I hope you understood this. There will be one more important part which is remaining out of this discussion. That is the part called after overhang there is something called equalizer. We have seen what is overhang. There is something called equalizer. First of all, we need to understand what is the equalizer. What is done? The conductors of same phase. I said conductors of same phase. Say I am drawing one line here, which is say the line for R phase. So conductors of R phase will be connected to this line. Likewise, conductors of R phase over the length of winding are connected to this line. This connection, what I have shown here, is called equalizer. The reason behind using the equalizer is sometimes practically, even though the conductors are of R phase, due to some short circuit in the winding or due to some problems, the voltages at different points of same phase will not be similar. So in order to make them similar, this equalizer connection is used. So I hope you will understand many things those were not understood earlier before this session. This session I hope will be useful for all of you. I know all of us are in lockdown in view of corona, which is due to this coronavirus, everyone is in lockdown, and we may not be interacting directly, but through this video I hope you will understand few things. And in case you find any queries, if you have any difficulties related to this topic, please post me or please comment your queries. I will try to answer all your queries. I will try to give you answers of all queries. Apart from that, if you really like something in this video, if you have gained some knowledge in it, Please like this video and please subscribe to this channel. Thank you.